Hello, the topic for this course EMEE6002 Sustainability and Climate Change is smart grid. There are many different definitions of smart grid. According to the European Technologies Platform Smart Grid is a electricity network that can intelligently integrate the actions of all users connected to it, including the generator and the consumer, in order to provide a sustainable and reliable economical power source. According to the US Government of Energy, the smart grid is a self-healing which can recover and repair by itself, and also it enables active participations by the consumer. So consumer can also play a role not only to consume electricity, but to also generate electricity back to the network, and probably they can earn money from the electricity market. Smart grid also ensure high resiliency so that it can provide a stable and reliable power supply to the network. According to ABB, smart grid can provide both transmission and distributions, and also an integrations of renewable energy source. So in the lectures on solar energies and wind energies, we know that the characteristic of renewable energy is the intermittency. Sometimes we have solar energy, sometimes we don't, sometimes we have wind and sometimes we don't. So how can we provide a stable and reliable source for the consumer? Smart grid can help. It can average out the intermittencies of those renewable sources and make sure that a stable source can be provided. According to the US National Institutions of Standards and Technologies, NIST, so smart grids can provide a bidirectional flow. So it can flow energy not only from the power plant to the household. The household can also act as a generator. For example, you can install some solar panel at the rooftop, and then during the sunny day, your excess power can then feed back to the grid network, and you can play the role as a generator so that it can communicate and control the whole network with this bidirectional flow of energy. Nowadays, many countries develop smart grid because we want a reliable energy source. We want to mitigate the global climate change problem, and we therefore install a lot of renewable energy systems. In order to make those systems more reliable, smart grid is needed. So let's see this video to understand how the smart grid operates. So these are the keywords that answer why we need a smart grid. In order to enable renewable energies to solve the intermittency problem, we need smart grid. So there are not only one source from the power plant, there are multiple sources from household industry and also from the offshore wind farm. So they all together aggregate the energies to provide a stable energy output. And also resiliency is another keyword. So we don't rely on one source or one path. There are multiple paths. So therefore we use the term grid, which means a network, just like a web. So if any linkage from one point to another point is broken, no worry, we still have other connections. So that the reliability can be improved. It also allowed customer participations in the energy market. And today, there are lots of small village houses in the new territories in Hong Kong are now playing this game. They install solar panel and then sell energies to the power company. And these are the driving force for the development of a smart grid. First, we need a reliable and no emissions energy source in electricity form in the future. And also, there are many existing power grids are now aging. We have these infrastructures for a long time already, and some of the switchings may be still even using mechanical. So we need to upgrade those facilities and change it to digital with automatic control. In many countries, they protect the power company quite a lot because they have to spend a lot of investment in the infrastructure. But nowadays, the people are calling for an open market so that they have more choices. So in order to facilitate an open energy market, So we need a smart grid. This is what we have currently in traditional power grid network. The power source will transmit the power through the transmission network and then finally to the household. So this is a one-way process. From the power company, it could be a nuclear power plant, it could be a fossil fuel power plant, and then all the way from the overhead cables to the substations and then to your household. But for smart grid, so the connections will be multi-directional, and this is the modern smart grid. So the connections looks like a web, and the directions for energy flows are bi-directional. It could be from the power plants to the industry to the household, or reverse. When the household have excess power, then it can sell it back to, for example, the industry or business. So on the production side, it could be any form of energy, traditional fossil fuel or renewable energy like solar or wind or even nuclear energy. And then after passing through the smart grid network, and in the consumption side, it could be the household, the electric vehicle or the industry, and we need smart meter to do the metering and get feedback and real-time control of the energy flow. Therefore, in a city like this, there are power plants and the household, and energy will flow through the distribution line and to the industry and office. And at the same time, we need an energy storage. So quite often in some city, they make use of the reservoir to store energy and convert excess electric energies into potential energy in water in the reservoir. So they pump water from the low levels to a high level to store electric energies in forms of the potential energy. But when we want to restore the energy, we can then throw water from high level back to the low level and convert this potential energy back to electric energy. So this is the way that we can store electric energies in a massive scale. And at the same time, there could be an offshore wind farm or onshore wind farm that also provide other form of renewable energies for this smart grid network. And according to the US Institutions of Standards and Technologies, there are 7 entities for the smart grid framework, including operational, generations, transmission, distributions, and consumer, but also with market and the service provider. So in this framework, apart from the traditional flow, from the generations to transmission, distributions, and consumptions, so we also have automations, network management, and some market operations. We also have other elements such as network management, market operations, substation automations, and so on. So that we need to make use of smart meters and other control device to control the flow of energy, not only from the generations to the consumer. Because when there are energy surplus in the household, or the EV charging is full and want to release some of energy back to the smart grid network, so the smart grid and the smart meters can play the role and to control the directional flow. Therefore, using smart grids can achieve all these advantages. It can enable the use of renewable energy and make the network more efficient and reliable. At the same time, it can integrate with the electric vehicle. Let's consider if there are many EV running in the city, then charging the EV would be a problem. The traditional power network may not be able to cope with the demand, and we need a smart grid. And smart grid can also improve the demand response. When there's any sudden change in the demand, smart grid can cope with the sudden change and provide a stable electricity power to the network. When there are wind energy but no solar energy, or they have solar energy but no wind, the smart grid can then aggregate these two sources and then provide a stable output. And smart grid also enable vehicle to grid. So it can enable charging of electric vehicle in massive scale, and also it allows EV to release energy back to the grid network when there are surplus. So the battery of the EV will play a role as a buffer or the storage of the electricity supply in the smart grid. Not only the reservoir, but also a large pool of EV battery can also help to make the smart grid energy level more stable. And the smart meter is one of the key components in the smart grid network. So it helps to monitor the consumptions in real time. And another advantage is that the smart meter can also be connected to a communication network so that the real-time consumption data can be sent to the operator immediately, and they can then take any smart response. So hackers can then find out the usage pattern of this household, and they can know what's the time when there's nobody home and then break into the house. Therefore, we need more security measures in the smart meter. So smart grid enable the vehicle-to-grid network and also enable the use of renewable energies for the charging of your EV. If your EV cannot be charged by renewable energy, we just use traditional fossil fuels to charge your EV, then electric vehicle cannot solve the emission problem. We just simply shift the emissions from the roadside emissions from the engines to the power plant. But thanks to vehicle-to-grid, we can convert the wind energies in AC form to DC, or the solar energies, which is in DC form, or the battery, all this into DC, and then connect it to the grid network and charge your electric vehicle. And at the same time, it can also release your energy back to the grid network. For example, last night you have fully charged your EV in your car park, and in the midnight time, the electricity charge is cheaper than during the peak hours, like during the daytime. Because during daytime, industry and companies also consume power. And in some countries, the electricity charge during that period of time is more expensive. So you charge your car overnight to enjoy the cheaper electricity charge. And then when you drive your car to your office, you can discharge the excess energies in the battery and send it back to the grid network and sell it at a higher price. However, by repeating charging and discharging your battery every day, the life of your battery may be shortened, and then it will create another problem. Let's say the disposals of the battery after a period of time, and the disposal of battery may be more polluting. Therefore, although the vehicle-to-grid have solved the problem of charging, but it may also create another problem of battery life. So as a summary, there are many advantages of smart grid. Okay, it's reliable and efficient. It can also avoid power outage because all the networks are connected as a grid or in the web form. It's more stable and it enables vehicle-to-grid and solve the charging problem of the electric vehicle. However, there are problems of smart grid as well. Although vehicle-to-grid is good for the EV charging, but it also creates the privacy and security issues. Nowadays, we have more and more devices using DC. For example, your laptop, LED lights, your mobile phone, they are all DCs. But the power network or the smart grid are still using AC. So there's lots of conversions between AC and DC, DC to AC, and so on. And this conversions is not very efficient. And for the commercial issues, the concept of smart grid is good. So everyone can be the player. Everyone can generate electricity and sell it to the network. So how can we integrate the existing player and the new player in this electricity market? And what about the price? Could we charge the electricity traffic according to different time or according to different operators? So these are the challenges that we need to solve.